Not mine. God's, but the ones that I get to lead. Help lead. There we go. Anyway, long story short. Here's a graph of the function. We talked yesterday about how if we're given an original, f prime will be the slopes, f double prime will be the concavity. We didn't get to fill in like anything. So, kiddos, what's the domain of f? All real numbers except g. So therefore, x doesn't equal g. What's the domain of f prime? AKA, where's the function differentiable, right? Same thing. Where's the function? Everywhere but g? What were or what are things that we should be looking out for when we talk about the differentiability of a function? Vertical tangent lines, and I don't have one because this one's still slanted, right? Okay. What else? Sharp points, which I don't have because I have smooth curves all over the place. And then jumps or other discontinuities. Good. So vertical asymptotes, holes, or jumps. Which is the sneakiest one that kind of flies under the radar a little bit? Jumps, vertical asymptotes, or holes? I guess vertical asymptotes and holes look really similar in the original function, but what I was thinking was the piecewise functions where the derivatives seem to match, but it was actually a hole in the beginning. Or where the slopes seem to match, so going in and going out, whether it's a jump or a hole, it could be either one. A piecewise function where the slopes actually do match, but the discontinuity says, no, 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 derivative does not exist. How about f double prime's domain? This one's a little bit harder to think about, but the answer is really just as easy as the other two. It's the same. But why? What do we think about when thinking about where the derivative does or does not exist? The first derivative, yeah, if we have functions, how can we think about it with graphs? What's the second derivative describe again? So where would there be non-existent concavity? But there could be concavity at horizontal tangents, the second derivative test, right? So there will be concavity at horizontal tangent lines. Yeah, linear. We'd have to look out for linear. But it could be possible the second derivative is just 0. So that wouldn't necessarily not exist. You'd have to look out for sharp points and vertical tangent lines of the first derivative, or DNEs of the first derivative, combined with DNEs of the original function. So we'd look out for sharp points. How would a first derivative have a sharp point? So it exists, but it's sharp. How could first derivative have a sharp point where it exists? That's the idea, right? Because a sharp point would be, well, it actually wouldn't be the original having a sharp turn. If the original had a sharp turn, the derivative wouldn't exist. I wonder if the derivative will ever have a sharp point, or if, when it comes to a sharp point, it will always have a hole. Because it wouldn't exist if there was a sharp change. That's a good question. I don't know if I know the answer to that one off the top of my head. Because every time I can think about a derivative having a sharp point, like say absolute value of x, right? The absolute value of x has a derivative with an absolute value, but the derivative doesn't exist at x equals 0 because of the sharp point. So where it would have a sharp point, it doesn't even exist. I don't know. The first derivative can be infinite, though, at a vertical tangent line. So I guess that could be a place. A vertical tangent, the second derivative wouldn't exist. Or continuities. Anyway, that's a much harder question to answer. And we'll ponder. They don't actually ever, I don't think, ask for domain of the second derivative specifically from a graph of the original. That's a little bit beyond their scope of questioning. But we do have to think about the domain of the second derivative in thinking about pips, right? Question, where's the original function increasing or decreasing? The original, where's f increasing or decreasing? No, it's in this table. Where's f increasing or decreasing? Increasing. Yeah? E to G. Yeah, open, right? Anything else? Yeah. Wait, why split up at G then? Why not just have it go straight through? Because it's increasing from E to infinity. I have to split up at G. There's a discontinuity. Good. This isn't an option. There's not an option. Okay, so where's the function decreasing? B to E, and that's it, right? Okay. Where's F prime? Ooh. Lo siento. Erase the little greater than less than. Sorry. Where's F prime increasing? There you go. Where's F prime increasing? I know. Sorry, I didn't mean to have that written. You guys are erasing it, right? Where's F prime increasing? Not A to B. I'm going to put A to B in the decreasing column. You guys see why? Because it's a big positive going closer and closer to 0. Positives going to 0 is a decrease. So A to B would be decreasing. E to G is increasing. So what's going on between B and E? Oh, so wait, it wasn't just from A to B, wasn't it from A to E? Do you guys see why? Don't positives go to 0 and then go to negatives? Aren't the numbers decreasing that whole time? Wait a minute, how can we tell that the slopes are decreasing that whole time? Now pause, actually, we're wrong. It's not A to E and it's not E to G, but it is A to something and it is something to G. It's just not E. Why am I going to say C? And what happens at the point of inflection? And what happens when concavity changes? F changes from increasing to decreasing or decreasing to increasing because the sign of the second derivative is the increasing decreasing of the first derivative. Couldn't I have just seen the concavity and been like, oh yeah, the slopes are decreasing whenever the second derivative is negative? Right? Negative back to 0, back to positive. So thinking about a number line, I'm going from positives to 0 to negatives, and then I'm going back to 0, back to positives. So I'm decreasing only until the point of inflection, and then I go the other way, just as far as the numeric values of the slope. Whew, that was a little bit of a struggle. Would it have been easier, instead of looking at the graph and thinking about the slopes, would it have been easier just to look at the concavity? I think so. What's going on here, though? What are the slopes doing? The whole time. Why? Positives going closer and closer and closer and closer and closer to hitting it. But, guys, what have? Yeah, so that's another reason why decreasing the whole time from G to infinity. What's the struggle of F double prime if we're thinking about F double prime's increasing, decreasing nature? We have to look at F triple prime. Do we have a way of looking at F triple prime with a graph? So we're not going to be answering that question. We're not going to be answering that question. Now, technically, I did just kind of change up just a little bit how my table works. We're going to go back to the original way how I meant the table to work, but I did want you guys to think through F prime's increasing and decreasing nature apart from this next question. It would have been a little too easy if I had just gone straight to the next question. So this one, I'm just going to say concave up for the entire thing. Concave up for F. Concave down for F. So, when is F concave up? C to G. Then concave down for the rest. We've already kind of talked about that, right? So from A to C, technically from negative infinity. Sorry, we've just been starting at A the whole time, haven't we? I'll just mark that out. From A to C, We already talked about from G to infinity. So then what does the concave up, concave down nature? Because we can't talk about the concave up, concave down of f prime. That'd be looking at f triple prime. We can't talk about concave up, concave down of f double prime. That'd be looking at f to the fourth derivative. And yeah, let's not go there. We don't need to visualize on a graph anything higher than the second derivative, so that's okay. But let's talk about real quick. So the concave up nature of f deals with the signs of the second derivative, right? So what's going to be true about f double prime being positive? Isn't it just the exact same? F double prime being negative, the exact same? Because the concavity of f is directly a result of the sign of the second derivative, right? But that's not the only way that we know the concavity. Looking at a graph isn't the only way. Looking at the second derivative isn't the only way. We can also look at the first derivative, right? Where the first derivative is increasing, as we just kind of discovered up here. When the first derivative is increasing, the original is concave up, concave down. What's a little U mean in math? Why am I using it? Union means or. I can't use the and. I can't use the A without the line, the upside down U. I can't use and for intersection because then they would have to have shared values and they don't. Okay, so I don't love this chart. I did change up the meaning right here, but I wanted you guys to struggle with what does it mean for f prime to increase and decrease without remembering that it's directly a result of the sign of the second derivative, which can be seen in the concavity of the original. So this is kind of the biggest idea where you guys, without attaching it to concavity, it took us a while, right? So what's the easiest way to talk about f prime increasing or decreasing? To either think about f double prime sign or to think about the concavity of the original. Now, hold on. What's a really, really, really common specific example of a first derivative? Applied. Velocity. Good. So what if in a problem they were to ask you when velocity is increasing or decreasing? What should you be thinking of? Based on this whole activity. If they ask you where velocity is increasing or decreasing. Acceleration, positive or negative, or concavity of position. Does that make sense? What if they were to ask you where acceleration is increasing or decreasing? Third derivative. Yeah. Third derivative, which would be jerk. Positive or negative, or the concavity of f prime. Does that make sense? Okay. So anyway, if we attach increasing, decreasing of a rate to either of these, you guys, I think, will be fine. But when you were just given it, when you were just thrown it, you guys got thrown off for a bit. So just be careful. Our brains don't think very quickly about slopes increasing or decreasing just by looking at a graph. We have some issues with that. Okay. Quick application. Even though I know you guys know that, well, you should know, or you have the increasing, decreasing test in your forevers, you have the concavity test in the forevers. Remember, depending on the question, it might not be super clear, super obvious about what it's referring to. So when you're talking about the sign of the first derivative, you're looking at the rate of f, which they don't even always use velocity, right? If they're talking about something like population's rate, they're not going to say the velocity of population change. That's awkward. They're just going to use rate. So if you're talking about the rate of an original being positive or the rate of the original being negative, it's how the original is changing, aka f increasing, f decreasing. If we get the second derivative, specifically, that points to how the rate is changing. And we could call it acceleration, but we could also say the rate of the rate. And the reason why it's the rate of the rate, or since it's the rate of the rate, that's why we have those weird things like feet per second, miles per hour, meters per minute. Or if it's super snazzy and we're talking about like dVdt or dAdt, we might have even things like feet cubed per second, liters cubed per hour, etc., etc., etc. But what's this whole thing trying to get you guys ready for? Word problems. And just all the different ways that they could have you dealing with the first and second derivatives, whether given graphs, whether given scenarios, whether given functions, whether given tables. All the different weird things that could actually show up. Whether bananas, bless you, whether funnels, whether amusement park tickets, bless you. Whether biscuits and tea, whether population. What were the animals last year? Weren't there animals? Elk? Oh, it was elk. You're right. They went basic. You guys were trying to get too exciting with your guesses. Yeah. Were penguins 2 years ago? I think that was 2 years ago. I don't think you guys had penguins last year. Oh, yeah, you're right. The one that you took. Yeah. Underlying any and every word problem is an original, a rate, and a rate of a rate. In some way, shape, or form. Whether going forwards with differentiation or backwards with integration. That's what's really nice about calculus, is that at the foundation of any and every problem they give you are the exact same fundamental ideas. Absolute. How high is your y? You guys know. It's it's the, not We need critical numbers and we need endpoints. We're comparing actual values themselves. The highest is going to be our absolute max. The lowest is going to be the absolute min. However, this is what we talked about yesterday. I did a precursor to it. Maybe I was just having a little too much fun and should have just waited. But what if we have no endpoints? What if they give us an open interval? Or what if we have discontinuities so EVT doesn't necessarily apply? The table that you guys are writing down right now, find the critical numbers and the endpoints. Test the critical numbers and the endpoints. This is my, plug it in a table. You got to check the y's, not the derivatives, not the second derivatives. You got to check the y's, check the actual values of what they want the maximum of. Or the minimum of. Ooh, if they want the maximum velocity, though. You're looking at the second derivative for critical numbers. Anyway, we'll face it when it comes, if it comes. But this whole dealio in the top, the steps, only works nicely for continuous functions on closed this whole thing only finds the absolute max and the absolute min for continuous functions on closed intervals. And the AP loves to give you either functions that are discontinuous at points, so you have to consider them also, or open intervals just to change it up and make it more confusing. So that's what the little note is for down below. And we didn't even, I don't even think I really wrote a note on it last year. It was kind of like, when we see it, we'll deal with it. In AP practice, I don't think we really saw it before then. And I was like, wait guys, wait, you can't just do the table because it has a discontinuity, or wait, it's an open interval, you can't just do the table. So the long story short, if there aren't endpoints or if there are discontinuities, we have to consider the domain, consider those discontinuities by checking behavior. We have to include a sign chart. I mean, we probably should include a sign chart up here. and this is actually from my friend that went to an AP conference this past summer, another thing they have changed as to how they grade the AP. Because it used to be, and she's actually looking for clarification. I'm trying to get our math department on a Saturday in November to go to, there's a California Council, math teachers, whatever, down in Palm Springs. And this guy named Mr. Calculus, he's in Diamond Bar High School. And I don't know if he still does, but he had the highest national passing rate for A, B, and BC. At least his department. I mean, he did first and then his department. Public school, ironically. But he went down the hill to the middle school and he was like, no, I need these kids to be ready for me, so I'm going to work with you guys to get them ready. It's intense. But he had the highest passing rate for A, B, and BC for multiple years. Cool guy. But anyway, I'm going to try and go and clarify. He was the guy that gave the conference this summer that my friend went to. I've been to multiple workshops, but here's the sad thing. According to him, as far as what he said this summer, you will get points marked down if you don't include all candidates in the table, which stinks. Because I and friends of my other teachers would tell you guys you only have to include the logical ones. Meaning, if you're looking for the absolute max and you have a relative min, forget it. It can't be a candidate. It's a relative min. How could it be an absolute max? I think for the most part, I start off showing you plugging in all the critical numbers and all the endpoints, but I've always made it around AP practice time, like, oh, this guy doesn't matter. He's a relative min. Look at the sign chart. The bummer is they're going to take off points if you haven't included all the critical numbers and the endpoints in your analysis, even the relative mins and maxes. So sign charts are still important, but they totally will not consider, or I should say they will totally disregard any work in a sign chart. So if in a sign chart you were like, oh, hey, he's a relative min, I'm not going to consider him, they'll be like, well, you should have talked about it. Gotta love him. Gotta love him. Don't ask me why. But anyway, just something silly. We're just going to put in all the critical numbers and all the endpoints anytime we have to test candidates for absolute extrema. So ready, set? Take it away, cool kids. Take it away. But this one is an easy one. Why is it easy? It's a polynomial, which means he's continuous. And, well, yeah, and differentiable. And he's on a closed interval. EBT says there is an absolute mix, there is an absolute max, there is an absolute min. And it's going to happen at the critical points and or the endpoints. Super wordy, but that's okay, it'll do. It's the full explanation. What do you guys think is the most common question I get from kids who get the general idea of what they're supposed to be doing as they're solving for absolute extrema? Anybody know? If they have a general idea of what they're doing, critical numbers, endpoints, what do I always get? At least once, every time I review it. Where do you plug it in? But the only one that makes sense is if you're testing the heights, at the endpoints and the critical numbers as the candidates for the absolute extrema. You're testing the values to say who has the lowest value or who has the highest value. I have to be looking back at the original. What happened when you guys plugged in -1? What'd you get? What happened when you plugged in 0? What happened when you plugged in 1? How about 2? I think it's 16. Did anybody get there? Because 2 to the 4th is 16, 16 and 3 is 48, 48 and 32. Yeah, 16. So what's the lowest? Or maybe I should say has the lowest. I could put it that way. That's a little bit better. Has the lowest value. Has the lowest, the highest value. Yeah, my lowest one would be f of 0 equaling -1. My highest value would be f of... Oh, I wrote it backwards. Thanks, guys. I didn't look across. Struggles with having a smartboard. They just said find the extrema. So I went ahead and identified both the values and the at. They didn't say points. If they'd said points, I would have given them 1, -1, and 2, 16. If they just wanted the maximum value and the minimum value, I would have put -1 and 16. Not all that information is necessary per se, but I was talking about the domain, making sure there were no discontinuities, making sure I had my closed interval for my continuous function. Because of that, EBT applies. I can find my absolute max and min based on the lowest and the highest value when testing the candidates. I just kind of like wrote it all out to give you guys a full comprehensive grasp of everything that just went into that problem. Did we do a sign chart? No. Could we have? I suppose we could have. We could have, right? But because we had a continuous function on a closed interval, all we had to say is, hey, the candidates, there's going to be a max and min at one of these. Let's test the values. So this was an easy guy in that the sign chart was not necessary, right? What about this one? Let's just talk it through together, because you guys were just quiet for a long time, and I just talked for a long time. So let's talk it through together. I'm a puppet. I'm chilling. I'll only say something if I need to correct and no one catches you. Where should we start? Besides writing down the function. Okay, good idea. So how do I check that? What do you want me to put? F of x and then just do what I know how to do, or plug in this specific piece? What does that mean? Can I do this too? But now what? Where's my closed interval? Where are my endpoints? How can I make my table? Well, no. It still says the extreme values. So what's it still looking for? But what do you have to do? You have to broaden your analysis. You can't just do the table, because that only works for continuous functions on closed intervals. They said, hey, here's the whole guy from negative infinity to infinity. Deal with it. Is he continuous? Yeah. Great. Well, I don't have to worry about discontinuities, but what do I still need to do? What am I doing? Why am I writing it like, what did I change? Why can't it be equal to? It was back there. What's the big deal? The derivative's not continuous. Who am I taking the derivative of this time? Or sorry, the limit of this time? What's the derivative defined to be? Definition of derivative. Who is he? Slope of the tangent line. But where does he come from? Definition of derivative. F prime of x is equal to? Ah, he's a limit, and all limits must? And what do these not agree? Or where do these not agree? Come in from one direction, the slope is -4. Come in from the other direction, it's 1. What's this the definition of? Sharp point. They don't agree. So, why is it a big deal that I know that the derivative doesn't exist at 1? It's a critical point. Where are the other critical points? Are there any other ones? Does it equal 0 anywhere? That doesn't, but that's okay. This does. This does at 0, and 0 is in the right. Whew, all right. If 0 wasn't in the inequality, it wouldn't matter. At x equals 0, my critical numbers are x equals 0 and 1. Whew, all of that was just to figure out how to do a sign chart. So who do I put in my sign chart? You can still write the sign chart. They're just not allowed to give you any points based on what you say there, or what you figure out from there that you don't actually restate in your own words. Whose behavior do I really care about? Whose extremes am I really trying to find? So let's consider the behavior of f prime. Sorry, the sign of f prime to figure out the behavior of f, right? So, you guys plugging and chugging? If I have -1, it's going to be a positive, true? It meaning the derivative. F is going to be increasing. 1/2, still here, right? F prime is a negative, so increasing. And then at 1, sorry, past 1, 2. It's going to be positive from there on out. Increasing at a constant rate, still increasing. Struggle. Now what? I do have a relative max that I could defend, right, at x equals 0. I do have a relative min at x equals 1. But what's the struggle? If we were just asking for relative, I'd be good. I could stop. I mean, I'd have to defend my sign chart and say f prime is changing from positive to negative, or f is changing from increasing to decreasing at the critical number. And at the critical number, technically at the horizontal tangent line and at the sharp point. But if they were asking for absolute, can I just say absolute max, absolute min? Guys, you know he's a line, you know he's a parabola. What's the struggle if it's increasing from negative infinity? Where's it going? Check it, check it, check it, check it. You guys can do this. Don't I have some sort of parabola-ish thing, and then don't I have some sort of line-ish thing? And technically, if you look at what's going on, don't I have like a parabola-ish thing that comes down, and then I have a line-ish thing? Do I have an absolute max or min? No. So for my analysis, I would have to say, basically, my function does have two relative extrema, but there is no absolute extrema. And I'm not going to go through and defend all of it, writing it all out right this second. This is not an FRQ. But according to the sign chart, there's no absolute extrema because I know the nature of a parabola and a line that comes from negative infinity and it's going to go to positive infinity. I could defend the relative min and the relative max, right? The relative max, the relative min for sure. Now here's a dilemma. So did our book really just ask for the extreme values, the absolute extrema, when there were none? Well, here's the struggle. Do you know how our book sometimes has different terminology? Right? So when it says the extrema, here's the bummer. It means it wants the local and the absolute. Now, how is that a dilemma with the AP guys in the wording of their questions? When they say the extreme or the min or the max, who are they naturally referring to? But our book says absolute when it wants absolute, says local when it wants local, and says just extrema when it wants everybody. So that's something that you guys needed to know before homework. Yeah, but what do the AP guys still say? The max, the min means the absolute. But Justin, thinking back to the nature of the graph, actually thought about it from the very beginning and actually had most of our answers. He would have still had to find his vertex and find his sharp point. But anyway, no absolute, definitely two relative, and we have a rationale as to why. Dun, 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 dun. Hey, right in time. You got to take a picture of the homework. I think I have the classroom open. There he is, if you want him. Let me peek and make sure there aren't any other weird directions. I remember that whole extrema idea, which is a bummer, because for the AP, me saying the max, the min, it's perfect. Just to get to this book that just says, extrema is just the general category, and I just want you to find all of them. It's just a bummer. Guys, the beginning of homework is like matching graphs and stuff, and tables. You get into some sort of analysis around number 11. Hold on, pause. What do stationary points refer to again? True. Didn't we just have two critical points where only one was stationary? Only one was a zero of the derivative. The other one was the DNE. So if they distinguish between critical points and stationary are specifically the ones with zeros. How do I have you go? Around like the 40s, it's true and false. So you only have ones in between. Anything else? Identify the critical points, local extrema, not stationary points. I think you're okay. When they say extreme, it means relative and absolute. Get out of here, cool kids. I'll see you later. You do not need to give me FRQ defenses in this homework. You might want to think about it, but you do not need to be giving me paragraphs. Please don't. Life is going to be sad if you do. Right? Like, oh.